Hello, Math Topics kids. Welcome back. We're still doing a little bit of review from lessons that we had discussed prior to the break. Again, just trying to give you a chance to get caught back up after missing so much time of school. So today we're going to talk about application problems of trigonometry. So, where you take a real scenario, so to speak, real life scenario, and then you can apply trigonometry and find a solution. So the first thing is a little bit of vocabulary. When you read a problem and it talks about an angle of elevation, it says the angle you would look up from your natural horizontal line of sight. So if I'm standing here, chilling, and there's a bird flying, and I look up to see that bird, first thing we have is my natural horizontal line of sight. I'm just chilling, staring out, and then all of a sudden I look up to see this bird. Okay, when I look up to see that bird, that angle that I look up from my natural horizontal line of sight, that, my friends, is the angle of elevation. Sorry about my bad handwriting there. All right, and also this is horizontal line of sight. All right, angle of depression is very similar to that, except for instead of the angle that you look up from your natural horizontal line of sight, it's the angle that you look down. So suppose in this case I'm standing on top of a mountain. All right, and I see Derek chilling down here. This is Derek. All right, I'll be up here. I'll be blue. All right, so I'm chilling. This is my horizontal line of sight. Looking out, enjoying the beautiful day. And then I see Derek. And when I look down and see Derek, naturally I become depressed. So this is my angle of depression. And this is the horizontal line of sight. So just keep in mind that it's always compared to horizontal. Okay? So angle of elevation, angle of depression. Let's look at a couple examples. So first, Alexis standing on top of the school at a height of 100 feet. So we'll just draw a little rough sketch. All right. So here we have the school. Here's the ground. Here's Alexis. All right. He's 100 feet up in the air. So say, all right, Alexis is 100 feet up. All right, he looks down at an angle of depression of 65 degrees. Now remember, Alexis's normal horizontal line of sight is here. So if he looks down at an angle of depression, it's how far he looks down from here. This will be the angle of depression. And that was 65 degrees to see Eleanor. And Eleanor is standing right here. All right, let's see. How far from the base of the school is Eleanor? So I'm looking for this distance right here. So really, guys, I'm just going to take this diagram and I'm going to turn it, I'm going to try to at least, turn it into a right triangle. Let me cheat slightly here. Let's make a nice pretty right triangle. All right, booyah. All right, here's what I know. I know that this leg is 100 feet. I know that this is what I'm trying to find. Now notice, you guys, that my triangle that I just drew is this. And that 65 degrees is not inside of my triangle. So what I'm going to do is I'm going to use something we learned in geometry class, and that is alternate interior angles. So you'll notice this little Z, whoa, that was a bad attempt. But I'm trying to draw a little Z here. And you guys learned in geometry class that alternate interior angles are congruent. So if the angle of depression to look down to see Eleanor is 65 degrees, then the angle of elevation you would look up to see Alexis would also be 65 degrees. So I'm going to put a little 65 degrees in here. So one thing to note is that an angle of depression will always equal corresponding angle of elevation. And now I'll just use trigonometry, so, ka, toa, to solve the problem. All right, so relative to this angle, this is opposite, this is adjacent. So that means I'm going to use tangent, opposite and adjacent. So the tangent of 65 degrees is equal to 100 over x. All right, this is where you got to use your calculator. Make sure it's in the right mode. When you type in the tangent of 65, you should get 2.14. So try that and make sure you get the right thing. But now let's actually solve for x. So remember the little shortcut I showed you in solving a trig equation like this. I can swap these two guys, and I showed you this in the last video why that works. And so that means x is equal to 100 divided by the tangent of 65. So when I punch that in my calculator, and you guys should be punching buttons, we get 46.6 feet. That's how far Eleanor would be standing from the base of the school. Let's take a look at another one. All right, a plane begins its descent 30,000 feet in the air to land at DIA. So let me draw a little airplane here. It's actually not bad using this little crappy board. All right, here's the ground. It's supposed to be flat, but you know, bear with me. I'm a flat earther, as we know. All right, it's 30,000 feet up. And the ground distance, so the spot below the plane to the airport is 108 miles. Here's DIA, and that is 108 miles. But we know that 1 mile is equal to 5,280 feet. So I'm going to convert 108 miles by multiplying it by 5,280 to get that this is really 570,240 feet. You can punch that in your calculator and you'll see. All right. So, what is the angle of elevation from the airport to the plane? Chilling out here at the plane, or at the airport rather. The angle of elevation is how far you would look up. So I'm going to solve for this guy, theta. All right, now relative to that theta, here's my angle. This is adjacent. This is opposite. I don't care about the hypotenuse. So again, from SOHCAHTOA, I'm going to use tangent because I'm using opposite and adjacent. So the tangent of theta is equal to 30,000 over 570,240. Then in your calculator, when you're working backwards and you're solving for an angle, that's when you press the inverse tangent. In my calculator, it's second tangent. You got to find that little -1. All right? And when I type this in my calculator, inverse tangent, and then inside of my parentheses, I put this fraction, I get boom, about 3 degrees. So theta is approximately 3 degrees. That angle of elevation to look up to see that plane is only about 3 degrees. Sweet. So that's angle of depression and angle of elevation problems. And we did one of each. We used one to find the missing side length of the triangle, and we used another one here to find an angle measure within a right triangle. All right? Now you can also use this without angle of elevation or depression just to do what's called an indirect measurement. So in this problem, like suppose we want to find the distance across this lake. Well, I can't just grab a tape measure and measure directly across the lake. Maybe I don't have a boat or a long enough tape measure. So all I'm going to do is just use this right triangle here. And so the surveyor sets up 2 stakes. He puts one at A, puts one at B, and then he walks away from point B such that he's perpendicular to this segment AB to make a right triangle. And he knows he can measure this distance along the ground to be 500. And then he stands here at his little surveying station, his little tripod, and he can measure this angle between those 2 stakes to be 53 degrees. Just by looking this way, turning his head, looking that way, knowing, hey, that angle is 53 degrees from this point between those two. And all we're going to do now is solve for x. And again, I guess I'm not very creative, huh? These are all tangent problems. If this is my angle, this is opposite, this is adjacent, this is simply another tangent problem. So the tangent of 53 degrees is opposite, which is x, over adjacent, which is 500. And then to solve for x, I'll multiply both sides by 500. And I'll get that x is equal to 500 times the tangent of 53 which is 663.5. And you guys remember, if you're, and that will be feet, if you are not getting these answers correctly, but you're following the steps appropriately, make sure your calculator is in degree mode. And you can probably Google how to do that, depending on what type of calculator you have, or you can FaceTime me and ask me, or meet me in the conference room, or whatever. All right. Next is using bearings. All right. And again, we did this problem in class, but this is a reminder. Guys, have you ever used a compass, or even your cell phone has a compass on it? There's like a numeric equivalent of a direction. All right, like north is 0 degrees, and east is 90 degrees, south is 180 degrees, and west is 270 degrees. So if I said, hey, I live in Boulder, the mountains are west of me. So another way of saying they're west of me is I could say the mountains are on a bearing of 270 degrees. And that's just another way to say west. It's a bit more precise, because maybe I want to talk about where Long's Peak is. Well, Long's Peak is not just west of Boulder, it's also north. So maybe Long's Peak is more like 315 degrees, a bearing of 315 degrees. It's more precise. All right, so a pilot leaves an airport. So let's just start right here. Here's the airport. All right, and that pilot is traveling, let's use a little segment here so it's straight, due north. Pilot's going north. All right, and I can see north is up based on my compass over here. All right, after flying for 200 miles, she makes a right turn and flies on a bearing of 140 degrees. Now, you guys, I'm oversimplifying this. A plane cannot stop midair and just turn, right? It would kind of go around and do it, but, you know, we're just making this simple for you, all right? So she changed her bearing from 0 degrees, which was north, to 140 degrees. And you guys can note, and what I like to do with these types of problems is I put little compass rose at any time there's a change in bearings. This is 0 degrees, this is 90, this would be 180. So if now she's going 140 degrees, then she's traveling somewhere between 90 and 180, a little bit closer to 180. She's traveling on a bearing in this direction. Then it says, when the pilot is due east of the airport. Well, east, obviously, is to the right of the airport. There's my compass. So right here, she is due east of the airport. This is where the plane will be now. How far from the airport is she? Bam. We know that's a right angle because this was north of the airport, and this was east of the airport, and those form a right angle. How far from the airport is she? So the problem is that I don't have any angles inside of this triangle. But that's pretty easy to fix because I do know that all the way around is 180 degrees, but this is 140. That leaves 40 degrees left to get all the way back down to 180. Another thing you could do is that from here to here is 90, and that is 50 degrees past 90 to get to 140, and these two would add to 90 as well. So I know bearings problems are kind of tricky, and I'll just give you some really simple ones, I promise you, on assessment. But really, here's all we got. We just have a right triangle. I figured out that this was 40 degrees. I know that this is 200, and I want to find this, x. And again, not super creative, right? This is another tangent problem. Relative to this angle, this is opposite, and this is adjacent. So we'd say the tangent of 40 degrees is equal to x over 200. And when I multiply 200 by both sides, I get x is equal to 200 times the tangent of 40. And then I'll just punch out my calculator. And I get a round 168 feet, approximately. I got 167.8, so around 168 feet. And again, my handwriting sucks. The last part of this question says, hey, what bearing does she have to fly to get back to the airport? Well, if she is here currently, this is the plane, which bearing does she have to fly to go back this direction? Well, let's just look up on her compass. What bearing is back west? And I completely missed when I tried to draw west here. What bearing is back west? That's 270 degrees. So the bearing is 270 degrees. All right, so go to the quiz, and there'll be some problems that are very simple and very similar to these. All right, guys, I hope things are going well.